Good morning, sir. My name is Pragati Baba Sukhot. I'm standing before you to PPT presentation for the hill climbing algorithm. This slide is a contents of this PPT presentation, hill climbing algorithm, objective, introduction, meaning definition, hill climbing algorithm, principles, importance, essential components, types, how hill climbing algorithm works, algorithm, mechanism, benefits, advantages, challenges, limitations, applications, tools and technology, and outcome and reference. This is contents of the hill climbing algorithm. This slide present to the objective. So first object is a find an optimal solution by iteratively improving the current states. And the second is start with the initial solution to the problem. This means the hill climbing is a search algorithm. In the AI is usually find to the an optimal solution is a step by step. So evaluate. Third is evaluate neighboring solution to identify better candidates. Fourth is move to neighbor solution if it improves the objective functions. Six the process and found the optimal solution by iteratively improving the current state if no better neighbors are found. It means local optimal reached. Last one is aim to maximize or minimize the objective function based on the problem. This is objective. His introduction of the hill climbing algorithm is a simple and widely used in the optimization algorithm. It designed and to find the best solution, either maximum or minimum, to a problem by the iteratively improving the candidate solution. It is a classified the local search algorithm because it is considered the neighboring solution of a current state to the decide the next move. This algorithm is a search algorithm, is artificial intelligence used in to find the optimal solution step by step. And this is the algorithm always moves toward the best neighbor solution, similar to the climbing a hill to reach a peak. And it is greedy algorithm, making decision based on the intermediate benefits. The base algorithm start in the initial solution, which can be the randomly generated based on the some heuristic. Then explore the neighbor solution by making smaller changes and evaluate the object function values. The neighboring solution is better than the current one. So algorithm moves the neighbor. This is process repeated step by step. Climbing uphill, it is means maximize, and downhill, it is a minimize. So until no better neighbors exist, at this point the algorithm stop having found the local optimal. Hill climbing is a particularly useful for the problem with large search space, where exact search with compatibility expensive or impossible. Common application include machine learning, parameter tuning, path finding, scheduling, and many combination optimization problem. Why hill climbing? Because it is a simple and innovative approach for the optimization problem useful in AI like path finding, scheduling, and gameplay. Provide a foundation of understanding more complex search algorithm. This is introduction. So definition of algorithm, it is a local search optimization technique used to the solve tech optimization problem by the iterative improving a single candidate solution. It means hill climbing is heuristic search algorithm. It is a artificial intelligence that start in initial solution to iteratively moves to other neighboring solution with a better values aiming to reach the optimal solution. It is called as a hill climbing because the algorithm climbs step by step toward the peak, represent the best solution. Hill climbing is widely used because its simplicity and efficiency is navigating large and complex search space, where executive search is not feasible and commands applied in the artificial intelligence, machine learning, robotics, and other area requires quick approaches. This is definition. Next slide is a principle of hill climbing algorithm. Principle of hill climbing algorithm. It is a fundamental local search algorithm and it is widely used in the AI for the solve optimization problem. It operates by the starting from the initial solution and iteratively moving the neighboring solution to improve the objective function and evaluate how good a solution is. It means the start with an initial solution in a search space. So next is this process continues until no neighboring state yield a better value, indicating that because it is only consider immediate neighbors and choose the best available move without regard for the border space. Unaltered, simple and efficient, this approach can get stuck and local maxima or palettes with limits and ability to find the global optimum. The select the neighbors with the best value according to the object and heuristic functions. So move the better neighbor and repeat step 2 or 4 until no neighbor is better than the current solution. The peak is reached. And then the stop the current solution is considered the local optimum. May or may not be the global optimum. This is principle that underline many advanced search technique used in the AI problem solving and the decision making. So next slide is the importance of the hill climbing algorithm. Hill climb first is a simple to understand and implement. This is hill climbing algorithm. Its work as a easy to learn and easy to implement. Implement. Second is a fast and memory efficiency. Third is useful for the solving optimization problem. Fourth is can provide good approximate solution quickly. Fifth is a pouch the basic and other advanced algorithm. Sixth is help in understand local search technique and heuristic approach. Uh, the second is next slide is a essential component of hill climbing algorithm. First is current state. Second is neighboring state. Third is evaluation function. Fourth is move operator. Fifth is termination condition. So first one, current state. Current state is a essential solution. Start with essential solution and the starting for or current solution in a search. Next is neighboring state. It is a possible solution reachable from the current state by the making small changes. Third one is a evaluation function. That function can so evaluate the equal states. Fourth is move operator. The method use the transition from the current state to the neighboring state. Fifth is termination condition is a criteria to stop the algorithm. Example like a no better neighbors, max iteration reached. Uh, an example give you the repeat step until no neighbor is better than the current solution. So the stop the current solution is considered as a local optimum. So, next slide is a types of hill climbing algorithm. This is the sixth type of the algorithm. First one is a simple hill climbing algorithm. Simple hill climbing algorithm, it means a move to the first better neighbor, it's fine. And second point is does not backtrack, can get stuck at a local algorithm. It advantage is a simple and fast, and disadvantage is a may miss the global optimum. Second is a step-based ascent hill climbing algorithm. It means the evaluate all neighbors and moves to the that one with the best improvement. The second is a slower than simple and hill climbing algorithm, but more like reach a higher peak. This is static hill climbing algorithm. It means the randomly select the neighbor and moves either better. Introduce the random to avoid getting stuck in the local maximum. This is third. Fourth is a coordinate algorithm. Coordinate algorithm, it means randomly select the neighbor until the better one in the found. This moves immediately, and the it random restart hill climbing. It means the sequential. It means the efficient in the large surface, and cons is a may miss optimal solution. Last one is a random restart hill climbing algorithm. It is a run multiple hill climbing searches from the different problem starting points. This is advantage is a help escape local maxima and find global optimal. And disadvantages require more computational times. This is type of algorithm. Next slide is how he'll working the he. Start with an initial solution. It means the choose a random or define starting point in a search space. Second is evaluate its quality using the objective function. It is a use a heuristic or objective function to measure its quality. Third one is generate neighboring solution by the small changes. It is a look at all possible next move from the current solution. Select fifth is a select the best neighbor with improved value. It is a choose the neighbor with the highest value for maximization or lowest value for the minimization. Sixth step is a how to these better neighbors it is improve this solution. It is update and current to be the better neighbors and repeat the process from the new solution. It is a continue evaluation neighbor and moving to the better solution until it is a no neighbor is a better local maximum is a reached or a stopping condition is met. Eight one is a stop when no neighbor improves the solution. Local optimal reach. It means the algorithm output the best solution found. Maybe it's local or global optimals. The next slide is the algorithm. Algorithm is a start with the initial solution. This is current state. Second is evaluate the finite values, the current state. Third one is a generate neighboring state on the current state. Fourth one is evaluate the fitness of each neighbors. Fifth one is if neighbor has been better fitness, moves that the neighbor. And sixth is repeat step 2 or 5 until the no better neighbor exists the local optima reached. This is the algorithm of the hill climbing algorithm. The next slide is a mechanism of the hill climbing algorithm. So first point is a initialization. Initialization it means the begin with a random selected initial solution from the search space. Okay. So second is a fitness evaluation. It means the calculate the fitness uh, like this objective or function values on the current solution. Third one is a neighbor generation. It is a generate the neighboring solution by applying small changes of the current solution. Fourth is a neighbor evaluation. It is the evaluates the fitness of each neighbor solution. Fifth is a selection and moves. It means the if a neighbor has a better fitness than a current solution, move to that the neighbor. Sixth is termination check. It is a stop if no better neighbor exists on the limit is a reached. This is mechanism for the hill climbing algorithm. The next slide is application. There many how many application there is a artificial intelligence, robotics, scaling problem, machine learning, optimization research, control system, optimization problem. This is how many to many applications. So it is a benefits and advantage of the hill climbing algorithm. First point is a simple and easy to implement. That means the algorithm is conceptually straightforward or required little conditioned efforts. Second is a fast and memory efficient. It only store the current state, making a suitable for the limited resource environment. Third one is a good for local optimization, quickly coverage and acceptable on locally optimal solution. How many problems? This is the advantages. So next slide is a challenges and limitations. So this is a six challenges and limitation. First is a random restart. Second is a simulated annealing. Third is a static hill climbing. This is a type of hill climbing and this is a challenge for the hill climbing. Fourth one is a backtracking. Backtracking is a try the different option and if not doesn't work so to the back and the try another function. This is backtracking. Fifth is a steepest ascent and sixth is a multi-objective. So next is a tools. Tools it is a state representation, objective function, operator, stopping conditions. This is purpose and role in algorithm. So next slide is a techniques. Techniques for the five techniques and this is different description. First is simple hill climbing. This is the simplest approach. It moves the first neighboring state, show the environment. Second is the steepest ascent hill climbing. The more computational, intensive repent and it eliminates the neighbor and moves to the one that offer the greatest improve in the object function. Third is stochastic hill climbing algorithm. Adds randomness to the move. Choose the random among neighbors that show the improvedness. Fourth is a random restart hill climbing. The most effective is technology. If a start get a local optimum, it restart and enter search from the new and random selected essential. And last one is a stimulated annealing. While not no pure hill climbing algorithm, it is advanced built upon the concept and it is introduce the temperature parameter allow the accuracy moves to the worst case helping to the search temporarily except the local optimal. This is technique. Second is a real world example. So this is example for the a factory needs to assign the jobs to the different machine to minimize the total computation time. So high work, challenges, enhancement, this is etc. etc. Next slide is the outcome. First is a local optimal form. The algorithm often covers the local maximum and minimum where no better neighboring solution exists. Second is fast coverage. Third is a solution quality depends on a start. Fifth one is a simple and efficient, and last one is may require the multiple runs. This is a conclusion of this PPT. Hill climbing is a straightforward and effective local search algorithm used to solve the potmeter problem with iteratively improve kinetic solution. It starts from the essential solution, moves the step by step to neighboring solution with better values, aiming find the optimal to search space with the anomaly. Thank you.